Today we'll pick up on vector embeddings, which I personally believe to be quite a set of important tech behind the entire native wave and work that's being done. Also, the foundation behind processing, understanding, and making sense out of unstructured data. Yeah, like, and also personal opinion, I feel they have a far wider use case because of the nature of how they can be used and how they're already being getting used. Yeah. So early, if I, if you want, why should we care about vector embeddings, right? So probably these are some of the use cases I've recently seen, right? So there are trading firms which are using vector embeddings to make sense of call transcripts and other unstructured data, like relationship between different firms and stuff. They have largely been already being used quite frequently or extensively for product recommendation by e-commerce companies. And then third, probably a fairly common use cases, probably for answer retrieval or FAQ section and stuff, right? So what exactly are vector embeddings, right? So they're a way to represent unstructured data in a vector dimensional form, which is processable or can be processed by your computer systems. And why are they called vectors? Because this form of representation involves turning a certain piece of unstructured data into different vectors with a set of dimensions. A vector in this case being, let's say, a 512 dimensions vector, then you're basically looking at 512 different numerical values assigned to each of the object, right? And this is something that gets learned or trained uh, privately, like it was, the methods like glove and stuff. Now there are other various deep learning methods to do that. So yeah, you basically take a piece of unstructured data, you probably break into parts or chunks, as we call it, and then each chunk gets represented by a vector, right? Similar to how your mathematical operations, you involve vectors, right? And depending on the number of dimensions, like if you have 512, then you have a 512 numbers to represent a vector. If you want to build a more complex representation, you can use 1,000 and so on and so forth. So the other question is, why this representation? So yeah, like, I mean, the reason is because fundamentally there's a lot of semantic information to an unstructured data. What I mean is semantic information is the different words, if it's probably a text, or different pieces of the image, right, have a relationship that conveys some information, the color, the texture, things like that. And being able to represent it in numerical form is necessary so that you can actually build intelligence or learning over it. Right? And this is where your vector embeddings come into use case, right? So fundamental level, what you're trying to do is take this dense information that's available, create a representation of it that we can understand, learn it, and then try to run intelligence and stuff over it. And now that you have turned this unstructured form to numerical form, you can do a bunch of mathematical operations, executions over it. So what are the important questions, right? Like, so I think when you're doing this kind of a representation learning, or similar to how any ML model works, right? How do you know when to stop, right? How to choose between different vector approaches, models, or frameworks, right? And yeah, like, how do you know whether the model or the representation that you have created is good enough or not? Uh, the other question that some of the firms or companies might have is, should we be building them on our own for a use case, or should we just be using pre-built embedding models from some of these companies, right? Largely, if you're looking at the FANG ones, they are the ones who are driving majority of the innovation. They're pushing their boundaries. They have the capital, uh, the human resources, and the infrastructure to pull this off, right? So they pretty much are expected and will be continue to expect them to push the boundaries. But when it comes to, let's say, early stage companies or some of the SaaS firms, right, you might not really be building things from scratch. You likely will either be, most likely will be using a pre-built embedding model as is, or make it basically doing some bit of fine tuning to tune it to your use case. That leaves us a, some kind of a gap in between where there are these mid-scale firms, other consumer companies, which are not necessarily in the range of banks, but again, they also run large-scale businesses, have a lot of data, customers, and stuff like that. This is where it gets interesting, where there's a fair bit of mix of approaches that probably will come out. Some of them building their own, but probably might attempt to build their own, and some of them, uh, you know, would probably be using off-the-shelf funds, fine-tune it, and use it, right? But this is where there's a lot of ambiguity or how they might want to do it, right? But yeah, like, just to summarize the question, should you be building custom embeddings? In my personal opinion, the early days you probably are better off just using off-the-shelf stuff. Close the entire loop off, get the whole thing working, and once you're done with that, and you have you've figured out, whether the stack works, everything works fine. You've seen some kind of improvement, and you can measure in the areas where it's not working is where you probably might want to go back and see if it makes sense to build or invest further in the solution or the approach. But yeah, like, so what are the different embedding models, pre-built models already available? So you have this Hugging Face leaderboard for different embedding models, and it has a bunch of metrics around it to give you a sense of trade-off between each one of them. But I think this is a good place to start and think about specific embedding model if you just want to pick it off, right? Thank you.